Assalamualaikum warahmatullahi wabarakatuh and good morning to all my students. Okay, in this video, we're going to continue our discussion on topic 2, first order linear differential equation. And for this topic, we're going to look into two different methods here. Okay. The first is separable variables and first order linear differential equation. Separable variables, it means we are talking about we call the root word of separate. We separate the variables between x and y, for example, and before we integrate the function left and right. Okay. To use both of the, we call the method that we saw on the first, we call the previous slides of page, we are going to, distinguish between general and particular solution. General, that the equation will end up with a constant of c, and particular solution means that we get the exact value without the, end up the answers with a c when we given to us the value of a and b. Okay, well, the value of x and also y, and solve separable differential equation, and also this one here, solve the first order linear differential equation by means of an integrating factor. Okay, now differential equation is an equation involving one or more derivative of an unknown function. So a differential equation is equation which is related as unknown function of a single variable with one or more of its derivative. Okay, so dy dx and something like this from here. Okay, never mind, rejecting that. If we look at example, it might be called clearer than all this. Okay. In this topic, we only focus on first order linear differential equation. Okay, given the function of y equal to 3x squared plus x minus 2, so derive or differentiate y with respect to the x, and it gives you 3x squared plus differentiate of 3x squared give you 6x, and this one here, different derivative of negative 2 equal to 0. Now reverse the process. Reverse the process. Given that dy dx equal to 6x plus 1, so we integrate y and also integrate the function of fx dx, and you will get back almost the same as the y from the original question here. So that is the purpose of differential equation. We try to find out back what is the function in the term of y equal to fx. So two types of the solution for differential equation. Okay, general solution, and given if x equal to 1 and y equal to 4, the same function here, we substitute y and x, it gives us the value of c. So then it ends up with y equal to x cubed over 3 plus 11 over 3, meaning that it's a complete equation without any constant or the letter of c here. So two methods of solving differential equation: separation of variables method, separable variables, and integrating factors method. Okay, so for this one here now, which I think that, okay, a differential equation of dy dx equal to fx times gy is separable if it can be written in the form of 1 over gy dy equal to fx dx. So class, I just assume that on left side of this is equal to equation symbol here. So on left side is all the house of y, and on the right side or the other side of this sign here is a y, is the house of x. As you can see here now, there's no variable of x left here, and there's no variable of y left here. It's all y, and here is all x. So step is separate from the dy dx here into y dy and also fx dx. Then integrate both sides here, like something like that one here now. And then, okay, find the general solution for the following differential equation. Okay, so this one here now, dy dx equal to 2xy. As I mentioned just now, let's one on the left side is all house of y, and on the other side of this side here is a house of x. So we get y here. So just imagine that if 2 times x times y, we like to bring out y to the side, means that we are going to multiply with 1 over y here and also multiply with 1 over y. So, and then dx bring to the other side and come up with 1 over y. dy equal to 2x dx. Okay, before we continue with the integral process here, do you find any x left on this side? No, right? It's all y and y. And you find any y left here? Nope. It's all x and x. So we are complete separate the variables, as in now time for now for us to integral left and right. So integral of 1 over y, we come up with natural log of y equal to, and this one here 2 is a constant, integral of x squared divided by 2 plus c. Okay, so 2 divided by 2, then natural log of y equal to x squared plus c. Class, we wanted to end this answer in the form of y equal to fx. And what we have here right now is natural log of y. It's not in terms of y, single y here. So we come up with we call the constant of e here and also here. So between ln and also e to the power of natural log here is cancelling each other. It's come up with y equal to e power of x squared plus c. And look at this one here now. A to the power of n plus n equal to a to the power of m. Yes, and multiply with a to the power of n. So then here now, e to the power of x squared multiply with e to the power of c. Okay, and then y equal to ex squared times e to the power of c. We simplify this. We e is a constant, to the power of c is a constant. It's just like 2 to the power of 3. If we left this as an answer, final answer here, it's not very nice, right? 2 power of 3. Why don't we just let it as a constant of 8? So it is here y equal to a e to the power of x squared. Okay, by left a short note here where a equal to e to the power of c. So this is the simplest form. The simplest form of the final solution for question number example 1a. Okay, question B. Dy dx equal to y squared e power of negative 2x. So this is the house of y and this is the house of x. Between this side here, so we separate, here is a house of y and is house of x. So we're going to bring this y squared to the other side. It is now 1 over y squared dy equal to e power of negative 2x dx. Okay. So we are going to integrate left and right, and this one here is we treat as a y negative 2 dy equal to integral of e power of negative 2x dx. Okay, integral y power of negative 2 is y power of negative 2 plus 1. Negative 2 plus 1, negative 1 divided by negative 1 equal to e power of negative 2x divided by, okay, integral of this e power of negative 2x, we call the exponential here, e power negative 2x divided by derivative of negative 2x, yes, negative 2 plus c. Okay, so negative and y power of negative, which is 1 over y, equal to negative 1 over 2 e power of negative 2x plus c. Okay, and then multiply negative left and right to eliminate this sign of negative here, come up with 1 over y equal to negative times negative, positive, positive times negative, negative. So 1 over 2 e power of negative 2x minus c. Okay, and we simplify this as an e power of negative 2x minus 2c divided by 2. Then y equal to 2 divided by e power of negative 2x minus 2c. This is it. Okay, y equal to 2 divided by e power negative 2x minus 2c. Okay. Example 2. For each of the DE, find a particular solution that satisfies the given condition here. Okay. Question A. 1 over x dy dx equal to square root of 1 plus x squared, given that x equal to 0 and y equal to 0. Okay, so we are going to bring this dx and also x to the other side. So come out with dy equal to x. Do you find any y here? No. Okay, so x multiplied with all this square root of 1 plus x squared dx. Okay, let's double check. Do you find any x left here? No. And do you find any y left here? No. Okay, so it's complete now. We separate all the variables between y and x. So we integrate left and right. So integral of 1 dy? Yes, y. Okay, now let's take a look at this one here now. If I make this something like this, square root of 1 plus x squared multiplied with x dx. Okay. The reason why I switch the position of this multiplication, 2 times 3 or 3 times 2 is still the same, right? Okay, let u equal to 1 plus x squared. So then du equal to 2x dx. Okay, 1 plus x squared, 1 plus x squared, which is our u here, and we have x dx, but what we have here is 2x dx. So it means that come up with du over 2 equal to an x dx. Okay, so now it's time for y equal to integral of 1 plus x squared u power of half x dx, which is du over 2. There you go. That's the reason that I changed the position between x and also square root of 1 plus x squared. So we can substitute clearly here. It is 1 over 2 integral of u power of 1 over 2 du. Okay. So now, it is 1 over 2 integral of, 1 over 2 integral of this, okay, u, integral of u half, u power of 1 over 2, 1 over 2 plus 1, or 1 over 2 plus 2 over 2, which is u to the power of 3 over 2, divide by 3 over 2, or change it as a 2 over 3. Okay, and plus with, okay, plus with c, and 2 divided by 2, so come out here with 1 over 3, 1 over 3, and change the u in the term of 1 plus x squared power of 3 over 2. Okay, sorry. Plus c. Okay. Y equal to 1 plus x squared power of 3 over 2. And, okay, 1 over 3 here. And plus c. Okay, now, the substitution method part here is all complete, and integration is all here. Y equal to 1 over 3 times 1 plus x squared power of 3 over 2 plus c. So it's time for us now to substitute y equal to 0 and x equal to 0. So when x equal to 0, y equal to 0, y 0 equal to 1 over 3, 1 plus 0 squared to the power of 3 over 2 plus c. Okay, 0 squared is 0, 1 plus 0, and then 1 power of 3 over 2 is still 1, times 1 over 3 is 1 over 3 plus c, 0 here, where c equal to negative 1 over 3. This one here now. So, get back to this equation here now. Y equal to 1 over 3 to the power of 1 plus x squared to the power of 3 over 2 minus 1 over 3. Okay, which I think that this is more than enough. Even though we can simplify this over 3, it's just like 1 plus x squared power of 3 over 2 minus 1 divided by 3. Yet it's still the same. Okay, next one. Question B. Question B, 1 over x dy dx equal to y squared cos x, given that y pi equal to 1. Meaning here, when x equal to pi and y equal to 1. Okay, so from here, we get y squared. So bring the side become 1 over y squared dy equal to, we got x and also dx here, x multiplied with cos x dx. Okay, so integrate left and right. Integral of y power of negative 2 dy equal to integral of x cos x dx. So integral of this, come out with y power of negative 2 plus 1, negative 1 divided by negative 1 equal to, okay, now look at this one. And this reminds us to we call the subtopic in chapter 1 that we need to use the integration by part. You still remember that? Okay, when we need to consider whether the function between this and this with the hints of L, P, E, T. So N stands for log, P polynomial, E exponent, and T trigonometric function. So between x and cos x, this is x represent, yes, polynomial, and cos x is trigo. So it means that here we choose the u equal to nx and dv equal to cos x dx. So differentiate this u equal to nx, du equal to dx, and integrate this left and right. So the v equal to differentiate cos, it gives you negative sign. Integrate cos, it gives you sine x. Okay, so then integration by part, do you still remember that? uv minus integral of v du. Okay, u and v x sine x, uv minus integral of v sine x du equal to dx, x sine x minus integral of sine. Okay, integral of cos give you sine, integral of sine give you negative cos x plus c. So simplify this, and this one here negative here, and y power of negative 1 over y, and then this one here equal to x sine x plus cos x plus c. Okay, so then what's next? Until here, negative 1 over y, it's time for us now to substitute with the value of x equal to pi and y equal to 1. So then y equal to 1, negative 1 over 1 or negative 1 equal to x equal to pi and sine pi plus with cos pi plus c. Okay, so it's between this one and this one here now. This is a graph of sine x, where this is the value of pi and this is the graph of cos x. Okay. Cos pi equal to sine pi. Sine, this is a graph of sine x and this is a graph of cos x with 1 and also negative 1. So sine pi equal to 0, this is 0, and cos pi equal to negative 1 plus c. So then c equal to negative 1, bring to the side, become positive. So negative 1 plus 1, 0. C equal to 0. So then, get back to this equation here now. Here, again, negative 1 over y equal to x sine x plus cos x, and c is already find it here, which is equal to 0. So there is no constant left. And then y equal to negative 1 divided by x sine x plus cos x. There you go. Okay, integrating factor method. Given that dy dx minus y all that equal to 1. So we cannot separate between the y and x to separate y on left side and x on the other side. So it's a linear, so it can be all solved using the integrating factor. It's called a linear first order differential equation. And in general form, in general form here, dy dx plus px times y, px multiplied y equal to qx. And from this p, then we come up with the integrating factor of v, which is equal to e to the power of integral of px dx. And how to solve this? From the general equation here, get px and qx. And find the integrating factor of v. Okay, some books they use the ix, integrating factor. Integrating factor I here, they come up with ix or vx is just a symbol, it's still the same. And then multiply equation 1 with integrating factor and multiply with all this one. So then write down as here, integrate both left and right. Then solve vx times y equal to integral of vx qx dx. Okay, example 3. Okay, solve dy dx plus y over x equal to x squared. Now, if we write down in the form of dy dx plus px times y equal to qx, okay, it seems like if I transform this equation into this form, we come up with dy dx plus 1 over x times y equal to x squared, where px equal to 1 over x and qx equal to x squared. Okay, let's try. Now, dy dx plus y over x equal to x squared. Okay, so we list down the px, which is 1 over x here, and qx equal to x squared. Okay, the integrating factor of vx equal to e to the power of integral of 1 over x dx. E integral of 1 over x, integral of 1 over x dx equal to natural log of x. Am I right? You still remember? Yeah, good. Now, this one here come up with natural log of x. Okay. And between these two, e to the power of natural log cancel each other, then it come up with the term of x. So, x is the integrating factor that we're going to multiply with the this one here now. Okay, class. Refer this with the we call the general equation of this. It's exactly the same because there is no variable of x and or y here. This equation exactly is in this form, dy dx plus px times y, and then qx, which is x squared. So, x multiplied with dy dx multiply x with every single term here, plus with x times y over x equal to x multiplied with x squared. Okay, so here we can simplify this one as a dx of xy equal to x cubed. Okay, this one we can simplify in this form of derivative of x times y respect to the x. And now integral this to the x and also integral this to the x. Okay, so the integration and differentiation is cancelling each other here. So now you come out with xy equal to integral of x cubed dx. Okay, so you come out with x to the power of 4 divided by 4 plus c. Okay, we want it in the form of y equal to fx. Y equal to fx means that we need to bring this x to the other side. So then y equal to divide by x. So then x power of 4 divided by 4, and let's say if I may imagine this one as a xy multiplied with 1 over x. So also here come up with 1 over x plus c times 1 over x. This one and this one here. So it is y equal to x cubed divided by 4 plus with c divided by x. Okay, we leave it in general form because it's not given us to the value of x and y. If given to us the value of x and y, we can simply find out what is the value of c here. At this moment, there is no value of x and y given here, so we leave this in general form or with the constant of c. Example 4. Okay, now we compare with dy dx plus bx times y equal to qx. Okay, what's the difference between this equation from the question here with this general form? Yes, we got this one, x. In general form, dy dx is a single without multiplication with any variable or any numbers here. So at this point here, x dy dx minus y equal to x squared sine 2x. Divide by x, multiply with 1 over x here, then dy dx minus divide by x and divide by x, y divide by x equal to x squared divided by x, x sine 2x. Okay, so now according to this one here, plus, so px equal to negative 1 over x, negative, and here is positive. Okay, and then qx equal to x sine 2x. Okay, px is negative 1 over x, and also qx x sine 2x. Okay, so v integrated factor e to the power of integral of 1 over x negative dx. Okay, so e power of negative integral of 1 over x natural log of x, and this one here negative, bring up here, become power of -1. So e power of natural log of x power of -1, between e and ln cancel each other, then it's now become 1 over x. Okay, and now this is the Vx or integrating factor. Are we going to multiply this with the equation here? Nope. Okay, because this equation here is not in general form of this, because dy dx, what we have here is x multiplied with dy dx. So then we will multiply this with this one. Okay, because this one is exactly same in this as this form, dy dx, pxy, and then qx, x and x dx. So px is -1 over x. Okay, now, okay, if I this one here, what if I multiply with this one here? Yeah, that's it. Okay, now okay, 1 over x multiplied with dy dx, and then minus 1 over x, and then multiply with y divided by x, equal to 1 over x here multiplied with x sine 2x. Okay, and look at this one here. Now we can simplify this in the form of dx with the integrating factor of 1 over x multiplied with y, equal to x divided by x, and you come up with sine 2x. Okay, so now integrate left and right. Between integration and differentiation, cancelling each other here. So 1 over x times y equal to integral of sine 2x dx. Integral of sine, okay, differentiate sine give you cos, integrate sine give negative cos 2x divided by derivative of 2x, 2 c. Okay, so we want it in the form of y equal to fx. So then right now, multiply with x here, multiply with x and x. So then y equal to negative x cos 2x divided by 2 plus with cx. There you go. Okay, so according to the question at my notes here, then we call it factorize, take it the x outside and let the rest of this in the bracket still same. Okay, example 5. Okay, now x dy dx equal to x squared e power of negative x minus xy. Okay, so then here now we divide by x here, so we come up with dy dx equal to x divided by x equal to 1, x squared divided by x, then x e power of negative x minus x divided by x, 1, and y. Okay, bring this to the other side. Plus y equal to x e power of negative x. Okay, we compare with this one here, dy dx plus px times y equal to qx. From this question here, we get x multiplied with dy dx. In general form of integrating factor here, dy dx is a single, not multiplied with any variable of any numbers here. So it means that this is the one that exactly in this form. dy dx, px times y plus y, and then x e power of negative x. Okay, so we list down where px equal to, okay, we imagine that there's one here. So px times y, so there's no x, so we consider the p with the variable of x here, which is equal to 1. And qx equal to x e power of negative x. So then, integrating factor of vx here, which is equal to e power of integral of 1 dx. Okay, integral of 1 dx equal to x, right? Okay, now this is the integrating factor that we're going to multiply with this equation here. Because this equation is exactly the same as in the general here. The equation from this question, it has x multiplied with dy dx, which is not exactly the same as this one because dy dx is much singular, not multiplied with any x as this one here. Okay, so ex multiplied with dy dx plus ex times y equal to ex multiplied with an x multiplied with e power of negative x. Okay, and this one here now we simplify as d respect to the x is a multiplication of integrating factor of ex with y. Okay, and look at this one here now, e power of x and e power of negative x. E power of x times e power of negative x, which is e power of x. E power of negative is 1 over ex equal to 1. So between these two, only x left here. Get it? Okay. Now, d dx, where ex times y equal to an x. So, now this one here. Okay, this one here, bring here. Okay, now integrate left dx and integrate x dx. So then ex times y equal to, okay, integral of x to dx. Integral of x dx, which is x squared divided by 2 plus c. Okay, now, and now, given here, where x equal to 0, y equal to 1. So when x equal to 0, y equal to 1, we substitute here e power of 0, x equal to 0, e power of 0 times y equal to 1 equal to 0 squared over 2 plus c, when this is 0 here, e power of 0 equal to 1, 1 times 1 equal to 1, so the c equal to 1. So, ex times y equal to x squared over 2 plus c equal to 1. So then y equal to x squared divided by 2ex plus 1 over ex. Okay. Okay, for this one here now, is something like here. This one is e power of negative x and also x squared over 2 plus 1. This is more than enough, but this is the one that the simplest. E power of x here, denominator, bring above e power of negative x, and then x squared over 2 plus 1. Okay. So I do hope that with my explanation helps you to continue with the rest of the question paper from tutorial and past year questions. And that's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.